In this lesson, we're going to analyze a real Bitcoin transaction on the public Bitcoin blockchain. The idea will be so you can actually see a real transaction and you can see how all the different elements we have been discussing tie into a real transaction. For the purposes of this lesson, I have created two Bitcoin addresses and I'll be doing a transfer of 0.1 Bitcoins between these addresses. The idea would be that Alice would be sending 0.1 Bitcoins to Ben, and I'm actually doing real Bitcoin addresses so you can see all of that in the Bitcoin blockchain. As we stated, in order for Alice to be able to send Bitcoins to Ben, she needs to have Bitcoins. And as we said, for the purposes of this example, she has 20 Bitcoins inside her wallet, and Ben has a wallet of his own, and he has 10 Bitcoins in that wallet. For that, in order for Alice to be able to send 0.1 Bitcoins to Ben, Ben needs to provide her with his Bitcoin address. You will see right here a live Bitcoin address. And this is a real Bitcoin address, which if you go on the public blockchain, you'll be able to see that there's activity going into it. At this precise moment, we already know where the inputs and the outputs of this entire transaction are going to come from. The inputs are going to come from Alice, and the outputs are going to go to Ben, specifically to his Bitcoin address. Now, we are going to be transferring 0.1 Bitcoins to Ben from Alice's wallet. If we proceed with the transaction, we will actually have a transaction ID. For this point, this transaction ID is a real transaction, and you'll be able to see now as we proceed with this lesson how it all plays out on a Block Explorer. Let's do that right now and take that transaction ID and go into a Block Explorer. For the purposes of this lesson, I am actually using a Block Explorer found at btc.com, which has some very valuable views of how transactions play out on the blockchain. You can use any Block Explorer, but for this demo, I'm using btc.com. When I inserted that transaction ID and I did a lookup on btc.com, I find the transaction here. And what you find is that there are inputs and there are outputs. Among the outputs, there are two. There's one that includes Ben's Bitcoin address. You can see clearly here that the Bitcoin address I showed you is one of the outputs, and it has a 0.1 BTC that's destined to it. Let's go further into how this whole transaction is built. So we've got that in the output side, there are two outputs, and one of them corresponds to Ben's Bitcoin address. When we look at the input side, you'll see that there are three inputs. And these three inputs are all on this side, and you see that when you add them up, they give you a total of 0.28117926 Bitcoins, which is more than 0.1 Bitcoins. And the reason is that when Bitcoin processes transactions, you need to consume all outputs. So the wallet, when it was tasked with creating a transaction of sending 0.1 Bitcoins to Ben's Bitcoin address, it looked among all the unspent transaction outputs that it had, where those 20 Bitcoins came from, and it looked for different outputs that it could combine into one specific transaction. In this case, it found three inputs that she could put together to get more than 0.1 Bitcoins for the total of 0.28117926 Bitcoins. And we will be consuming that entire amount in this transaction. What we see is that the output really looks at 0.27949 323 Bitcoins. And that is more than 0.1 Bitcoins. If we were to just do the transaction like that, we would basically give the entire amount beyond that 0.1 Bitcoins to the miner. And that is a situation that in Bitcoin needs to be addressed on a per transaction basis. What happens then is that the wallet needs to specify what is the fee that goes to the miner. In this case, the fee has been established as 0.00168603 Bitcoins. And that's the amount that's going to go to the miners. That's why you see that the two outputs actually add up to 0.27949323 Bitcoins, because you are subtracting that miner fee from the total amount that came from the inputs. So let's go further into this. As we have specified that we have already determined what the fees are that go to the miner, we are left with two outputs. And you see that these two outputs, one of them is 0.100000 Bitcoins, which is what's going to go to Ben. But then there is another output, which is 0.1794933 Bitcoins. And let me specify how those are actually used, because we have two outputs in this transaction. The first one goes to Ben. As we said, it's 0.1 Bitcoins that goes to his Bitcoin address. But the second output is actually the change that goes back to Alice. And that is because we have specified that there's a transaction fee that goes to the miner. As we said, if you do not specify the transaction fee that goes to the miners and the wallet takes care of this, the entire amount beyond that 0.1 Bitcoins would have been given to the miners. And that's not what you want. The transaction is actually specified by the wallet, and it determines what is the fee that goes to the miner. So at this precise moment, what we have is that we have two outputs, 0.1 Bitcoins to go to Ben, and then a second output that is the change that goes back to Alice. When we go back into the specific Block Explorer, you see clearly that the inputs totaled the amount that we said. We said what the fees were that were going to go to the miner, and we're left with those two outputs. At this precise moment, these two outputs we're looking at, both the 0.1 Bitcoins that go to Ben and the change that goes back to Alice, are what is known as unspent transaction outputs. And the wallets, both Ben's wallet and Alice's, will actually be keeping these as potential outputs that they can use in future transactions. What this means is that Ben now has an unspent transaction output for 0.1 Bitcoins that he can use in a future transaction, and Alice, since she received the change, also has an unspent transaction output for 0.179493323 Bitcoins, which she can use in a future transaction. Now, in order to proceed this, I want to actually show you what happens next if Ben were to spend that unspent transaction output and Alice spends that unspent transaction output. What would happen is Ben would create a new transaction, which would go to someone else, and it would include this output, and Alice would create a new transaction on her side. Let's go ahead and do that. What we have is that we have created two new transactions. Transaction 3, which is Ben spending that 0.1 Bitcoins, and you'll be able to see these on a Block Explorer. And Alice proceeded to spend that 0.179493323 Bitcoins as well, and she has a corresponding hash for that transaction as well. What happens then is that these will no longer be unspent transaction outputs because they have already been spent in new transactions. Let's go back into the Block Explorer and see if we can actually look any further. When we look at those three specific inputs that we saw that were created into this transaction, if we click on them, you will also see that they have corresponding transaction IDs. And that is because Alice had taken those previously unspent transaction outputs and spent them in this transaction. So when you really see this whole equation, by this point, we have spent all of these Bitcoins, and you wind up with the entire picture. You have a transaction ID and a corresponding hash for every single one of these transactions that make up this real transaction on the Bitcoin blockchain.